Okay, hi everyone. Let's look at some example on error calculations using the two sets of formula that we have already introduced. So let's first start off with the first question. In the first question itself, the percentage error for L and G is respectively 3% and then 1%. So let's try and take a look at the percentage error for the period T in this case. So change in T over T, or if I can manipulate that here first, the L to the power of half and G to the power of minus half. Okay, so based on the formula that is here, if let's say it's n, I'm going to bring the n down. So in this case, I'll bring it down to half. All right, from here, change in L over L, and plus, even though it's minus half as we explained earlier, we still actually take the modulus and bring it down. All right, and make it a positive number, which is also half. Change in G over G. Okay, so based on that, in terms of percentage error for this, we can let it be half here, which is actually your 3%, plus your half, which is 1%. And with that, we can work out the number to be 1.5%. Okay, same as the significant figure for this. All right. So if not, we move forward to the next slide. This is the next equation we're looking at. So in the same way, we want to calculate the value for V, and then we can work out what is the error for V as well. So let's do the first step. So V is equal to actually 5 plus 10 times 20. Okay, that will give us 205. And mindful that all of them are two significant figures. This is 3. This is back to 2. All right, so this is 3 SF, which means you actually have to round up to 200. Next part, we calculate the error. The error part is actually a little bit more complicated. The first thing we have to calculate is the error for AT. For this, we still have to use division and multiplication. Then thereafter, we then add up the error based on the fact that the V, given the fact that V is equal to U plus AT. So we'll use a formula from this side. Okay, so let's start off by looking at the error. So let's take a look at the error of this first. So to look at the error of this, we'll be using multiplication and division, like we said. So A over T, that will be actually equal because it's A to the power of 1. So we'll be changing A over A to the power of 1 plus 1, changing T over T. Okay, so the change in A over T will be changing A here will be 0.1 divided by 10.1, and multiply by change in T will be 1 over 20, and you could actually multiply by the AT. AT will actually be 10.0 times 20. Okay. In the actual uncertainty, all right, is always one significant figure, all right. So therefore, because of that, we'll be rounding up to 10. Okay, so hence the value of V will be equal to 200 plus minus 10. This will be considered 1 SF, right? Or otherwise, if I do it in standard form, that's the way to represent it.